Okay, class, in this lesson, you're going to learn to identify angles in a unit circle. So let's go ahead and get started. All right, so let's first identify what a unit circle is, okay? So on a Cartesian coordinate with an x and y axis, we're going to go ahead and draw a circle. And what we're going to identify is that a unit circle has a specific radius, and that is, if I draw this red line here, this radius is 1, okay? So the radius of this particular circle, regardless of where it is, that radius is a unit measure of 1, and this is why we call this the unit circle, okay? Now, what's also unique about the unit circle is that when we create a right triangle, so let me go ahead and just draw that out for you. Okay, if we create a right triangle, what we notice is that the hypotenuse of this right triangle, it has a length of 1, okay? So that, in essence, is the unit circle. So let's go ahead and explore a little bit more about the unit circle. If we take a look at the right triangle trigonometry, okay, so what I mean by that is, let's go ahead and call this angle theta, okay? Now, as you recall, we learned this from the previous lesson. If we were to find the sine of theta, for example, okay, so let's say the sine of theta, as you know, is the opposite side over the hypotenuse. Okay, well, what is the opposite side? The opposite side is this length right here. Okay, so let's go ahead and call that y. Okay, the distance from here to here, we're going to label y. So this is y. All right, so then the sine of theta is y over, what is the length of the hypotenuse? Well, it is part of the unit circle, so we said that this is 1, right? So then this becomes 1. So in essence, sine of theta is just equal to y, okay? Sine of theta is equal to y. So keep that in mind for a second. Now let's take a look at the other side of the triangle. I'm going to call the base here x, okay? And if we were to take the cosine of theta, we know from our previous lesson that cosine of theta is the adjacent side over the hypotenuse. Okay, now if we take the adjacent side, so here's our angle, theta. The adjacent side here is x. So we know this to be x over, and the hypotenuse is 1, which simplifies to x, okay? So if you think about it this way, we know that x is equal to cosine theta. That means that this value here, this length here, is really cosine theta. And likewise, we know that y is equal to sine theta, which means this length here is also sine theta, okay? So what we are saying here is that x is the same thing as cosine theta, and y is the same thing as sine theta, okay? So what this results in is that instead of calling this point here x comma y, right? Because this is what the coordinate is over here, x comma y. It is also cosine theta, sine theta, okay? Now, this will come into play a little bit later, but the important thing here is to recognize that in addition to calling this x comma y, we can substitute that for cosine theta comma sine theta. And this is what's unique to a unit circle, because the radius is 1, which translates to the hypotenuse of that triangle. That value of 1 allows us to come up with cosine theta and sine theta, okay? All right, so let's go ahead and move on. So in this example, we are to find the coordinates of a point on the unit circle, and what we're going to have is an angle theta that has a measure of 60 degrees and a terminal side that intercepts the unit circle at x comma y. And the question is, what are the values of x and y? Okay, so first let's go ahead and draw the unit circle. And let's make sure this is centered, okay? And then we're going to have an angle theta I'm going to have a drop down here. I'm going to make this dotted, all right? And then we're going to go ahead and label this angle theta. And actually, I'm going to go ahead and label it 60 degrees because we were told that that angle theta is 60 degrees, okay? And the terminal side that intercepts the unit circle at x comma y, so this is going to be x comma y, okay? And the question is, what are the values of x and y? So we need to solve for this, okay? Now, if you recall, we have a 60, 30, 90 triangle, okay? If this is 60 degrees, then this has to be 30 degrees, okay? In a 60, 30, 90 degree triangle, okay, we know that the value of x, well, let me go ahead and just draw it over here to the side, just so that we have a refresher here. Okay, in a 60, 30, 90 degree triangle, I'm going to go ahead and label these, okay? The hypotenuse is really 2x. The length opposite the 30 degrees, okay, so here's 30 degrees. So the length opposite the 30 degrees is going to be x, or half the hypotenuse, okay? And then the length opposite the 60 degrees, which would be this side of the triangle, is square root of 3 times x, okay? Now, if we know, now going back to this unit circle, if we know in a unit circle that the length of the hypotenuse is 1, okay, so I'm going to go ahead and label this as 1, okay, then what do we know about the side opposite the 30, okay? We know that the side opposite the 30 is half the hypotenuse, right? X is half the hypotenuse. So half of 1 would have to be 1/2. Okay? And the side opposite the 60 degree angle is square root of 3 times x. So we're going to take square root of 3 times 1/2, and that'll give us square root of 3 halves. Okay? So the values of x and y are as follows. X comma y is going to equal 1/2 comma square root of 3 over 2. Okay? All right, let's move on. Here's example 2. Now we're going to talk about radian measures on the unit circle, okay? So what exactly is a radian measure of an angle? Okay, so first, what we're going to start with is the equation of a circumference, okay? So what is the circumference of a circle? Circumference basically is what it is the measure, okay, of this circle all the way around, one full rotation, okay? And the equation for the circumference of a circle is as follows. We're going to call circumference C, and that is equal to 2 pi times the radius, okay, times the radius. In a unit circle, okay, we know that the radius is equal to 1, okay? That's the unique nature of the unit circle. So if the radius is 1, then the circumference of the circle is really 2 pi times 1, okay, or 2 pi. Okay, so now what we know from what we just did is that if we were to start over here and we were to go all the way around the circle, that is equivalent to 2 pi, right? Okay, so let's go ahead and label that. We're going to start here at 0, and when we rotate all the way around, we're going to finish at 2 pi. So one full rotation, I'm going to call this one full rotation, okay? And this is going counterclockwise. One full rotation is equal to 2 pi. Well, if one full rotation is 2 pi, well then what is half of a rotation? Well, half of a rotation would be half of 2 pi, or it would be pi. So when you go 180 degrees, that is equivalent to pi. Now what would happen if we went 90 degrees? Well, that is half the rotation of a half rotation, which is pi. So half of pi would be pi over 2. Okay? And then likewise, if we were to go half a rotation and then another quarter rotation, that would give us 3 pi over 2. Okay, so 3 halves, right? This is 1 half, this is another half, this is a third half. Okay, and you can see that we can break this down even further. So if we were to go half of a rotation, then this point right here, halfway through, would be pi over 4. And then on this side over here, going part way or halfway between pi over 2 and pi, we would have 3 pi over 4. And then going all the way over here would give us 5 pi over 4. And then lastly, going halfway through this rotation in this quadrant, we'd have 7 pi over 4. Okay, so as you can see, we went from 0 all the way to 2 pi in one full rotation, and then we broke it down in half, so we got pi, and then we broke it down into further halves, right? So, or in quarters, so this is pi over 2, pi, 3 pi over 2, 2 pi, and then we broke it down into another, which would be eighths, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. We broke it down into 8 parts, and we found that this first eighth would be pi over 4, the second eighth would be pi over 2. The third eighth would be 3 pi over 4, and so on and so forth. So as you can see, we can break this down even further to whatever we would want. We could break it down into sixths. We can break it down into eighths, as we've already done. We can break it down to tenths. So the circle can be broken down to essentially any type of fraction. Okay? All right. So hopefully that makes sense about the radian measure. Okay? Now, we'll cover this in a little more detail in a minute, but I mentioned that when we go half a rotation, okay, we know that's 180 degrees. 180 degrees is in degree measure. However, in radian measure, 180 degrees is equivalent to pi, okay? So a full 360, a full rotation, which is 360 degrees, in radian measure, it is 2 pi, okay? And toward the end of this lesson, I'm going to show you how to make that conversion, but I wanted to make sure that you understood when I talk about 180 degrees or 1 pi radian, you understand that that's the equivalent, okay? Likewise, if we went a 90 degrees, okay, 90 degrees is the same thing as pi over 2. And then if you were to go 45 degrees, that's the same thing as pi over 4 in radian measure, okay? All right, so hopefully that made sense. Let's go ahead and move on. So this is basically a statement explaining what I just said. So the radian measure of a central angle, let me go ahead and pull up the diagram so you can kind of see what I'm talking about. So the radian measure of a central angle, so we're talking about the radian measure here of a central angle, is equal to the length of the arc on the unit circle subtended by that angle. So essentially what they're saying is this angle, whatever that measure is, it is the same as the length of this arc, okay? And the length of this arc is created by this angle here, by this radius and this starting point, okay? So where it subtends the unit circle, this portion here is the same. So if I were to go ahead and write this down, make this red, okay? That red is also equal to 1 because this radius is 1, and so this is also 1, okay? Now, if I were to identify another angle, let's say 3/4 pi, okay? We know this to be 3/4, okay? This angle is 3 pi over 4, and what this is also telling us is that this arc that I have in green is also 3 pi over 4, okay? And so the formula for theta, therefore, is right here. The angle theta, so whatever this angle is equal to the length of the intercepted arc divided by the radius, okay? Now, we know that from the unit circle, the radius is always 1, and so in this case, theta is just equal to the length of the intercepted arc, which is essentially the radian measure, okay? And this is why when we are looking at 3/4 pi, okay, this angle we know is 3/4 pi. It is the length of the arc is also the same. And the reason it's the same is because we're dividing by the radius of 1. Okay? So hopefully that was clear. So I've already explained this. The circumference of a circle, as I mentioned, is 2 pi r. Within the unit circle, we know that it is 2 pi. And so what that means is when we have a full rotation, that is 2 pi. Okay, one complete rotation is 2 pi. And then half a rotation is pi. And then a quarter rotation is pi over 2. And then 1/8 of a rotation will be pi over 4. Okay, now let's go on to the conversion, okay? Now, if you were to convert between degrees and radian, okay, the key thing to remember is this equation, okay, which is what I just explained. We know that one full rotation, 360 degrees, is equivalent to 2 pi radians, okay? Remember, one full rotation, 360 degrees, is the same thing as 2 pi. And we got 2 pi because the circumference of the circle is 2 pi. Well, it's 2 pi r, that's the equation, but because the radius is 1, it comes to 2 pi, okay? So we know that 2 pi radians is equivalent to 360 degrees, and this works out to 1 radian, therefore, is equal to 360 degrees divided by 2 pi, or 1 radian is equal to 180 degrees divided by pi, okay? So this is the ratio we want to use, 180 degrees over pi, or, depending on how we're converting, the ratio of pi over 180 degrees also applies, okay? So here's an example. Let's say we want to convert from degrees to radians, okay? So let's say we have 180 degrees, and we want to convert to radians. Okay, how many radians is that? Well, we're going to take 180 degrees, okay, and then we're going to multiply by this ratio here, pi over 180, okay, pi over 180, pi over 180, okay, and this works out to 180 pi over 180, and these cancel out, so it just works out to pi, right? And that makes sense, because in this example here, we were saying that if we were to go halfway around the circle, that's 180 degrees, and we know that halfway around is also pi, okay? So that makes sense, all right? And then likewise, let's say we wanted to convert from radians to degrees, okay? Let's see how we do that. So let's say that we have pi over 2 radians, okay? Pi over 2 radians, and we want to convert it to degrees. So how many degrees is that? Well, we're going to take pi over 2, and we're going to multiply by 180 degrees over pi, and this results in 180 degrees pi over 2 pi. The pi's cancel out, and 180 divided by 2 gives us 90 degrees. Okay, so that makes sense, right? We now know that pi over 2 converts to 90 degrees. Well, let's go back to this circle here. Pi over 2 is over here, right? This is pi over 2, and that is equivalent to 90 degrees, right? We're only going a quarter of the way around, so that gives us 90 degrees. Now, for some students, converting this sometimes is difficult because you're sometimes wondering, well, how do I know which of these ratios to use, okay? So if you think about what we did here, if we start out with a degree, okay, and we want to end up in radian, we want the numerator to be what we want the final answer to be. And so this ratio has a radian in the numerator and a degree on the bottom, and so we're going to use this ratio because the radian's on top. Okay. On the other hand, here we are converting from radians to degrees. The final answer we want is to be degrees. So this ratio is what we're going to use because the degree is in the numerator. Okay, and with a radian in the denominator, it'll end up canceling out this radian measure. Okay, all right, so I covered a lot, and hopefully this made sense to you, but you may want to go back to the beginning of this recording and listen to it again just to pick up any details you may have missed. Okay, thank you very much.